References for criteria and credits related to engine companies are shown here. Before we address the engine companies themselves, we need to talk about a couple of items that affect them. The first is the concept of basic fire flow. The basic fire flow comes into play in several areas of your rating. Here's how we determine what the basic fire flow is for each graded area in the state. Property Insurance Association manages a database of commercial properties in Louisiana. For each property, information related to building size, height, construction, and occupancies is made available to property insurers. PIAL uses formulas found in ISO's Guide to Determination of Needed Fire Flow to calculate, for insurance rating purposes, the amount of water required to fight a large-scale fire in each property in the database. Once the rates are calculated for every commercial property in the graded area, the list is sorted and the fifth highest needed fire flow is deemed to be the basic fire flow. PIAL caps the basic fire flow at 3,500 GPM, even in areas where the calculated basic fire flow may be higher. The chart on this slide shows the number of engines each graded area needs related to their basic fire flow. There are two ways we've seen confusion with this. First, please do not confuse this with the number of engines required to respond to structural fire alarms. We'll talk more about this in a minute. Second, please do not believe that if your basic fire flow is 3,000 GPM and you have two 1,500 GPM pumpers, that you can meet the needed engine requirement with just two pumpers. That is not true. Three engines are needed when the basic fire flow is 3,000 GPM. The basic fire flow simply defines the minimum number of engines the graded area needs to have to meet the calculated fire flow requirements. The second area we need to address before we can discuss credit for engine companies is automatic aid. The difference between automatic and mutual aid is timing. If a neighboring fire department is paged and responds on first alarm as if that equipment were your own, it is eligible for consideration as automatic aid. If the graded area fire department makes the decision to dispatch the neighboring fire department, either while en route to or at the location of the alarm, this is a mutual aid call. Only engines and ladder or service trucks and their manpower are creditable in the grading. But what about tankers? Tankers are not creditable in the grading, but if they respond as agreed upon in an automatic aid agreement, they may be considered as first alarm trucks on a water hauling lineup. Apart from manpower, automatic aid is only valid when it is needed, and it is only needed when the graded area cannot meet its own needs with their own equipment. We will address the manpower exception in another presentation dealing strictly with manpower. Automatic aid may be needed because the graded area has a basic fire flow that requires 3 engines and they have fewer than that, or it may require 2 engines and they only have 1. Or it may be needed because of the geographical limits in the response areas of the graded area's own pumpers. To be valid, the automatic aid apparatus must respond under a legal contract or resolution, such as an automatic aid agreement, memorandum of agreement, or similar document, and the apparatus must be dispatched on first alarm to all structural fire alarms within the area defined in the agreement. When automatic aid apparatus is being credited in your grading, automatic aid factor is calculated for each responding automatic aid apparatus. Once calculated, this factor is used to prorate the value of the automatic aid equipment or manpower throughout the grading. There are 6 areas that PIAL evaluates in building the automatic aid factor. The first involves an evaluation of the PSAP used to dispatch the automatic aid apparatus. Most of the time, this is the same PSAP used to dispatch the graded areas apparatus, but it can be different. Second, if there is more than one PSAP involved, there should be little or no delay in completing the dispatch of the automatic aid apparatus. Third, when the CAD system gives its dispatch recommendation to the dispatcher, that recommendation must include the automatic aid department. Fourth, members of the graded area and the automatic aid fire department must train together at least annually. Fifth, radio communications for each department must be interoperable at the dispatch and/or the tactical level. In other words, members of the individual fire departments need to be able to talk to each other on the radio. Finally, both fire departments must have common standard operating procedures that outline expectations and responsibilities for a first alarm response. Each automatic aid apparatus may earn any or all of these credits. We're now ready to look at the factors affecting engine company credits. Except for the automatic aid factor that is applied to automatic aid apparatus, there is no difference in how their equipment is credited and how the graded area's equipment is credited. Therefore, the following discussion will only address the graded area's apparatus. The end credit for engine company is comprised of the three factors shown here. The formula for calculating credit for engine companies is shown here. Note the placement of the various component parts. The total equipment credit for the existing engine companies is divided by the total possible equipment credit based on needed engine companies. Then the response factors are applied. We'll talk more about the response factors later. The resulting value is the percentage of the 6 points available for engine companies. Let's look closer now at how the component parts of this formula work. In exploring the factor EC, shown here in red, we see that the value of each engine company is determined by a pump capacity factor, a hose carried factor, and the value of the equipment carried on the engine. The total possible value of each engine is 600 points and is comprised of the credit for equipment carried as well as credit for hose and pump testing records. Required equipment for a pumper can be found in Annex A of the Fire Suppression Rating Schedule. There have been some changes, so I recommend you review this information. By looking at the formula for determining EC, you can easily see that if a pumper's pump capacity is less than 1,000 GPM, or if it carries less than 1,000 feet of 2.5-inch or larger supply hose and 200 feet of 2-inch, 2.5-inch, or 3-inch attack hose, or if it is not fully equipped, its value is less than 100%, so its factor will be less than 1, and if either of these values are less than 1, even a fully equipped and properly tested pumper will not receive the 600 points of credit as an engine company. By putting the subscript I at the end of the red EC found in the formula, we're saying that we are calculating the value of each engine and then adding them all together. We do that because in the denominator, we're going to multiply the 600 points possible by the number of needed engines for the graded area. So in essence, we're evaluating what you have compared to what you need and then moving on. An important thing to remember is that the number of existing engines will never be more than the number of needed engines. Let's look now at how that happens. So how many engines does the graded area actually need? We get this question all the time, and the answer is not as easy as you might think. The highest number, after evaluating three factors, will determine the number of needed engines. Remember during our discussion of basic fire flow, we used the chart shown here to determine how many engines were needed. There will never be more than 3 engines needed by basic fire flow because it is capped at 3,500 GPM, and 3 engines are needed for a basic fire flow of 3,500 GPM. This is the first consideration. The second is the number of fire stations where a pumper that was used during the graded year is housed. If a station houses a pumper that was not used during the graded year, PIAL must evaluate why that pumper wasn't used because normally we do not award credit for anything that you have that you don't need, and if you have a pumper but don't use it, the easy assumption is that you don't need it. There are 2 exceptions here. We will do a road mile distribution study showing 7 road mile zones around each station where pumpers that were used are housed. We will then determine if the pumpers that were not used are housed in locations where their recognition as an existing engine company would prevent there being Class 10 areas, and if so, we will recognize that engine as both needed and existing at that location. The second exception comes into play if the unused engine was not used simply because there were no alarms in the area where it would be expected to respond. For PIAL to make this exception, there must be a predefined response plan, and we will plot the locations of alarms on a GIS map to validate that there were no alarms in that pumper's response area. If there were not, then that pumper would be recognized as both needed and existing at that location. Finally, there's the graded areas method of operations. How many engines the graded area needs to respond with to structural fires is defined by the basic fire flow, but it will never exceed more than 2. In areas where the basic fire flow is less than 1250 GPM, any structural fire alarm with at least one engine responding has an adequate response, and the responding engine is considered as a needed engine. In areas where the basic fire flow is 1250 GPM or higher, an adequate response would include at least 2 pumpers. For working fires, responding pumpers are counted only if they arrive on scene. For non-working alarms, responding engines are counted if they departed their fire station. In areas that need to respond with 2 engines, any pumper that is used as a necessary part of a 2-engine response is considered as a needed engine. In this case, the value of I in the formula is the percentage of alarms with a 2-engine response, and I prime is the percentage of alarms with only a 1-engine response. If there were alarms that did not have an engine company response, I and I prime will not add up to 100%. In areas where only one engine is required to respond, I is the percentage of alarms with at least one engine responding, and I prime is the percentage of alarms with no engines responding. When all structural fire alarms, that is, working and non-working fire alarms, receive an adequate response, the value of I in this formula is 100%, and the value of I prime is 0. With this in mind, it can easily be seen that to receive all 6 points for available engine companies, all existing in-service engine companies must have pumps rated at 1000 GPM or more, they must carry a full hose load, and they must be 100% equipped. In addition, you must have the engine companies that you need, and finally, you must have an adequate engine company response on all structural fire alarms, both working and non-working. As always, we at the Property Insurance Association hope this information has been useful to you. If you should have any questions about this presentation or any other rating-related topic, please do not hesitate to call. In closing, I'd like to thank you for your time and attention, and I hope you have a great day.